Hello, class, and welcome back. We are now moving on to section 5. And I'm assuming you noticed that when I did section 1, after I recorded them all, I realized, oh my goodness, I did it long ways. And I was more concerned with getting the whole page. But then my son recommended, Dad, you really should do it horizontally. So I changed over, and that just helps you see much more of the book. It's a little more clearer, and it allows you to focus more on what we're working on, seeing a little more. It just makes it more convenient. Fills up your whole screen, makes it bigger. You should see it better. So hopefully this looks better now. Okay, well, let's move on to section 5. And in section 5, you remember when we started, there were 3 ways that you could calculate compounding interest. The first way, we found out that was a bear, where you could, for each compounding period, calculate the simple interest due, and then recalculate the principal for the next compounding period, so on and so forth. So you had to do as many calculations as there were compounding periods, and we realized quickly we don't want to do that. Mathematicians are lazy. All right. So we also then introduced tables so that the tables ahead of time are figured out, and you can use those to calculate your interest, your compounded amount, I should say. And then once you figured out your compounded amount, you can then subtract the principal, and that would give you the compound interest for all the time periods together. What we're going to do now is use the formula. So you don't even need a table. You can just use the formula. And this is the compounding interest formula. All right. So we're going to find the compounding amount. The formula is written here. So it is A equals P times the quantity 1 plus I. And then that quantity alone is raised to the nth power. It's an exponent. So on your calculators, you will need to learn how to use exponents here. All right. So let's start explaining what each thing is, okay? So A is the compounding amount. So we have that. We know that's what we want to find. That's how much we will have in interest and principal when it's all done, basically the future value. We want to know the principal. That's what P is. So that's the money we start with. And then we have in parentheses here, 1 plus I. Now I, this lowercase I, is actually the interest rate per period. So that's interest rate per compounding period. So realize that you have to know how often it's being compounded, and then take your nominal interest rate per year and divide it by the number of periods in the year, and that gives you the interest rate per period. All right? Then we need to figure out the total compounding periods, and we realize that is taking the number of years we are compounding for times how many periods within a year. So if it's 2 years and you're compounding quarterly, that would be 2 times 4, so you'd have 8 total compounding periods. And our interest rate per period would be, let's say you have 12% interest and you're compounding quarterly. So that would be 12%. I should pull out a little pad of paper here. All right. So if I want to know my lowercase I, oops, forgive me, I kicked the camera. If I want to know my lowercase I, that's interest per period. Let's say I'm at 12% interest for the year, and it's compounding quarterly. So that's 4 times per year. 12 divided by 4 is 3. So my interest rate per period, per compounding period, is 3%. That's how you figure out lowercase I. We've been doing that already, but I just wanted to reiterate that. And then the total compounding periods are the number of years. So let's say it's 3 years times how often per year. So if it's semi-annually, then we know that that's twice. So that should give us 6 total compounding periods. So lowercase n is always the total compounding periods. And I is the interest rate per compounding period. All right. So that's how we figure that out. Okay, so let's go on what the book does here, and I'm now on page 350, is show you the steps here that you're supposed to take. So it says, hey, step 1 is within the parentheses, and oh my goodness, remember our algebra here. All right, in our algebra problem, we have parentheses. Please excuse my dear Aunt Sally, we do the parentheses first. So we have to add 1 to whatever our interest rate per compounding period is. So 1 plus that interest rate. Once you do that, plug that into your calculator. Then you raise that amount. Please excuse, the second is exponent. So once you do the parentheses, we're finished. Now we have to raise that amount, just what's in the parentheses, to my exponent. All right. And once you do that in your calculator, then you multiply that. That is now your factor. Remember how we found our factors on the table? That is how they're calculating the factor. But now we don't need the table anymore. And that is our factor that we multiply by the principal in order to get our compounded amount. Okay? So those are the steps that it walks you through. All right? So if we look at example 5, it should be pretty simple. Okay, use the compound interest formula to calculate the compound amount of $5,000 invested. Let me get my real pointer here. Invested at 10% interest compounded semi-annually for 3 years. Semi-annually is twice per year. So that means I'm going to have 2 times 3 or 6 total compounding periods. All right. And 10% interest. So as we go down here and figure that out, okay, we know that if it's twice per year, semi-annually, and 10% interest per year, then the interest, lowercase I, 10% divided by 2 would give us 5%. So my I in the formula, in this case, is 5%. Interest rate per period, per compounding period, is the nominal rate divided by how many times per year. So it's 5%. The total number of periods is then going to be 6. We said it was 3 years, semi-annually, times 2. So 6. So as we plug this in, A equals the principal times the quantity 1 plus I, which is interest rate per compounding period, and that within the parentheses is raised to the small n, which is total compounding periods. So A equals principal is 5,000 times the quantity 1 plus, we already said, the interest rate per period is 5%, so 0.05. And then we also said there are a total number of 6 compounding periods. So that's what that's raised to. That's what the exponent is. So 1 plus 0.05 is 1.05. So 5,000 times the quantity 1.05 raised to the 6. So now we take 1.05 and raise that to the 6th power. And as you can see, that's our factor. Now the table always rounded to 5 digits. Leave as many digits as you can. If you're using your calculator, just leave the digits there. All right. Multiply by your principal. So that should give you $6,700 and 4782. So if we round to the penny, that should round the 7 to an 8. So $6,700.48. And they give you a calculator sequence here. So 1 plus 05 equals, and then hit your exponent button, 6. And then once you get that amount, you multiply that by 5,000, and that gives you your compounded amount. All right. And then the interest on that would be, well, we know we invested how much? We invested $5,000. So that would mean $1,700.48 is my interest. All right. So that's a nice amount of interest. 10% a year is a high amount. So anyway, go ahead and practice on exercise 5. And then we will do it the try it exercise. All right. Exercise 5, use the compound interest formula to calculate the compound amount of $3,000 invested at 8% interest compounded quarterly for 5 years. All right, go ahead and do the try it exercise.